to cause any reaction. We've got to exceed that voltage. Yeah.
Would 2.07 be just as fast as putting in 5?
No, it would go faster if, and I have actually something to demonstrate that today. This comment at the bottom. Water, when it's pure, doesn't have any ions in it to flow around. So the current will not go through the system if it's just pure water. It's got to have some electrolyte added to it. This example that I have that I'm going to show you, it's got some sulfuric acid in there just to allow the charge to flow, for ions to migrate. Yes?
What,
Don't hold that thing out.
water doesn't break apart.
It electrolyzes, that's the word you're looking for.
Yeah.
It will. Are you asking me that?
No. Wouldn't it have enough, wouldn't it be electrolytes on its own?
No, because it electrolyzes from neutral water to neutral hydrogen gas, which is not an ion, and neutral oxygen gas, which is not an ion. So it doesn't create
It
a
lives better away from oxygen.
Yeah, when it dissociates, but that's such a low concentration of ions.
Okay, so when
Yeah, there's not enough ions in there to you need a good number of ions to run current through. Yep. So I'd like to show you this reaction.
doesn't water do a current that's like not supposed to drop your wire to the cover?
Yeah, because when you sit in the tub, the salts are leaving your body and making an electrolyte solution. Pure water, you can drop a hairdryer in all you want. Yep. But yeah, as soon as your body goes into it, it's going to get salty. Well, yeah, that's weird.
They're just atoms, that's the way I
Some are more salty than others. Raul, you're a little salty.
For what?
It's in your language.
Oh, I'm sorry. I'll try to sugar it up.
Sounds good. Sounds good. Thank you. Okay. Here's what I have. This is kind of a fancy, intricate-looking setup. I've been joking about platinum. This setup has real platinum for its electrodes. If you look at it, there's a little leaf of a metal there, real thin, of course. It's expensive if you buy a thick one. And then there's one over here. Those are our 2 electrodes. They are literally platinum. Come on in, Justin. Come see this. We're doing this for Saloni, and I want her to see the platinum. Zoom right in to show those 2 electrodes right there. That's platinum, my friends.
Now.
All right, that's good. That's good. This is the black terminal. I don't know if you can see it. See the black and the red? The black is the negative. Black is always negative. That is the source of the electrons. So when I turn this down, electrons will be flowing out of the black into here, and then they'll be flowing in through the red. That's the positive terminal. Did I tell you yesterday how I remember that? Yeah, black and red. I think of the championship 2004 Detroit Pistons. 2 stars on that team, Rip Hamilton and Ben Wallace. Rip, red is positive. Ben, black is negative. So that's how I'll never forget. Of course, you guys were pretty young. Rip Hamilton, Ben Wallace. Ben Wallace is big here. Yeah. Fear the fro. Great days. What's that?
Was Rip just positive and Ben just like a doubter?
No, they were both positive. But Rip, R-I-P, red is positive, and black is negative. So, yeah. Okay, so now if the electrons are flowing out of the black, what process will be happening here? Electrons will be coming into the water. What has to happen? Something has to gain those electrons. What do you call that? Come on, we've been talking about this. This is what electrolysis.
No. Yeah.
It's either oxidation or reduction. Right. Something has to gain electrons. Grrr! Gaining electrons is reduction. So reduction should happen here. And then electrons are flowing out of the water back into the power supply. So that means something must be giving off electrons over there. At the anode is where oxidation occurs. So this should be the cathode, that should be the anode. Now let's go ahead and take a look at this. I'm going to turn it on, but then there's a dial to control how much voltage the power supply is giving us. So right now it's all the way down. So I've turned the power on, nothing happening. This is my voltmeter, and this is an ammeter to measure current. We're going to talk about current later in the hour. I'm going to turn my dial up. If I go up to about 1 volt, maybe 1.5 volts, looking at my leaves of platinum, I see nothing. There's nothing happening. Because remember, you need at least 2.06 volts for something to happen. Right now, there is kind of a push on electrons, but there's not enough to break that water molecule apart. So if I go up just above 2, I go to about 2.5. Oh yes. Tell me what's happening. Bubbles. Bubbles. You can't see the bubbles through there, can you? All right, Justin, come on.
I just know the bubbles.
All right, okay, there are bubbles. Now, if we turn it up and increase the voltage, see bubbles?
Yeah.
Oh, nice. Increasing the voltage, I'm going to go up to about 5 volts.
Oh, dang.
You see a better stream of bubbles? Can you really see it, Raul, or is that just a random dang?
Oh, I see it now. Oh, I see
All right. Now, going up to about 10 volts.
Oh, wow. Oh, wow.
Oh my god. They're bubbles.
All right, so we can see we're generating gas. What gases are being generated? Take a look at the chemical equation. All right. Now my question for you, now can you guys sit down now that you see the bubbles? We'll be able to see this. I'm going to crank this even more. I'm take it up to 40,000. Oh, there we go. I was thinking the voltmeter is kind of sticky. So, I don't know, hopefully you can see from where you're sitting the stream of bubbles going up.
Yeah.
What's happening to the level of water? The bubbles are carrying a gas that's displacing the water. Now you have a middle column of water. Notice you can kind of track that column of water. See how it's going up? That's the water that's being displaced by these gases.
But shouldn't it be like decreasing because we're using up water
Eventually will, but not now.
The water
Not
level
gas.
here is going down. The water has to go somewhere, so it's being forced up this middle column. Which one of these has the hydrogen? Which one has the oxygen?
That one
Or
is
are they both
hydrogen.
the same?
That one is hydrogen and oxygen.
Okay, how do you know?
Because the
Positive
hydrogen
and
is the one that is the oxygen is the one that's reducing.
Yeah,
The
look
hydrogen
at
is
the
the one
reaction
that's
going this way. Oxygen is going from -2 to 0. What is oxygen doing?
oxygen is reducing.
No.
I mean oxidizing.
Oxidizing. It's easier to see the hydrogen. Hydrogen is going from
Yeah.
+1 down to 0. Hydrogen is reducing.
Yeah.
Yeah.
Swimming.
Which side is the reduction happening on? Remember, electrons are flowing out of the negative into here. What process happens here?
reduction.
That's where the electrons are coming in. Something has to gain the electrons. That's reduction. So what gas is being generated over here? That's the hydrogen. That's where the reduction is happening.
So hydrogen is the black side?
Yes. And then where the electrons are coming out of, something has to be getting rid of electrons. That's the oxygen going from -2 to 0. The oxidation. Oxidation is the loss of electrons. All right. So let's see. I was going to say something else about this. Oh, here's something very significant. What do you notice about the levels of water?
The volume is different for each one.
Yeah.
Hydrogen is twice as much.
Isn't that awesome? We should get 2 times as much hydrogen as oxygen, and sure enough, we are.
That's amazing. Wow.
I'm trying to not go too fast so you can kind of digest it.
Yeah.
Well, no, because the STP would be 0 degrees Celsius, not 0 degrees Celsius in here.
I'm confused. Why is the water in the middle one so much higher than the other one? I thought there was
Oh,
like
because
balance out.
the gases are being generated and going up these tubes, so they're displacing water. This thing is here for the water to have some place to go.
Oh, because that one is open, right?
Yeah, this is open up here.
That makes
Yep,
sense.
so the water just flowing up in there. And that's what that bulb is doing up here. It's like a reservoir for the water that gets displaced. Now, could we confirm that it's hydrogen that's in here?
Yeah.
Light
Light
it
it
up.
back. Light
Of
it
course!
Fire.
We can't generate hydrogen and just waste it. We should light it on fire.
Hold on. Sketch that story.
You should have started from the beginning.
Okay. You guys disconnected. You guys
It's about time.
Everyone, wear your goggles.
Fire.
Wear your goggles.
It's finding a fire.
No, only time you wear
So I'd love to be able to fill that test tube, and that's pretty close. All right.
Wait.
So I'm going to go ahead and turn this thing off, and the generation of bubbles immediately stops. So I'm going to collect the gas by doing this. I'm just going to release this valve.
You could die. I saved you.
Hydrogen treatment.
All right. Now hydrogen is a very low density. It's less dense than helium. So I can leave the test tube like this, knowing the hydrogen is trying to rise up, and it'll just stay like that.
Science.
Let's see if it really was hydrogen in there.
If you drop it, it's over.
Hold on. Go for it.
Hydrogen. That's it.
Wait, you didn't blow up.
Yeah, I'm holding it in my hand, Raul. What do you want? All right, so.
Wait, I want to see the oxygen one.
Oh, yeah, slow motion would be cool too.
Let's do it again.
Yeah. Now, I can only do it now. We'd have to go through the whole thing again.
Get it back on.
Yeah, do that.
Oh, no.
Do that. It was more interesting than like.
Oh, you want to do the oxygen?
All right. So anyway, that's very interesting. Now, Mr. Heppel just came in. He heard the pop last hour, and he came in. He was saying that when you're on the AP exam, the part of the free response was about this demonstration, and one of the questions was, how will you confirm the presence of the You've just seen it. You just collect it and light it and see if it pops.
I'll get at least one
We're
question.
all gonna get
right
fives. All of us.
I hope so. Not just they asked it one time, they're not probably going to ask it again. You know, stuff like this that you see, like all right, so we've got to move along because I've still got one other thing that we need to talk. Well, two other things, really. All right, now turn your videos off. I've been hinting about electrolyzing salt water rather than just liquid salt. This is the consideration that we have to do when we have an ionic compound dissolved in water. Yeah, I'll tell you, it's much easier when the ionic compound is pure and just melted down. The problems are easier. Because if we have NaCl aqueous, and we're electrolyzing, we're running a current through aqueous salt. Now, where the anode is, whatever's giving off electrons, there are two possible things that can oxidize at the anode. When you had pure salt, like liquid salt, what was happening at the anode? Who was, anode is oxidation. Who was oxidizing at the anode?
Hydrogen. Or oxygen.
No, there's no hydrogen oxide, it's just pure
yeah,
salt.
I'm thinking of them.
Yeah, the only thing that could give off electrons was the chloride ion. So the chloride was oxidizing. Now that we have water present with the chloride ion, either the chloride ion is going to oxidize or the water is going to oxidize, because water can oxidize too, we just saw it. Patrick?
It is only, you didn't run enough current. Wait, first what's the current,
The voltage?
the voltage potential that you need for NaCl?
Okay, that's a great question. That's what I'm going to get to. As soon as I uncover that valve, I'll be right there.
It was like online somewhere, like, so they created a car that runs on salt water. So is this how, like, using the salt, they can create a battery?
They probably were doing fuel cells, yeah, actually generating hydrogen
Like using
gas
this.
from it. Yeah, they're probably using something like that.
Okay.
It didn't look anything like that, but the reaction, I
Yeah.
think, is similar. Yeah. Because remember, I said we need some sulfuric acid to conduct the charge. They probably were using salt.